In this module, we're going to talk about expected value. And again, this is review from your first course. Remember, the idea of expected values can be to say, what is the value expected on average of a random variable? And so if you can imagine how you might come up with that, what you might do is I would need to know a couple of things. I need to know the values that that random variable can take on, so all the different values. And I also need to know the relative fraction with which each one of those values occurs. And so I need to take into account both the values of the random variable and their probabilities of occurrence. And so in the discrete case, what you would do is you would say, I'm going to add up, if you want, the different values that the random variable can take on. And I'm going to weight it by the probability that that value actually occurs. So this is the value of the random variable, and this is the relative frequency with which it occurs. And then what I would do is I would add up over all the possible values of that random variable, and that is what we actually call the expected value of x when x is a discrete random variable. Okay, so I'll start using the acronym or the short form RV, not recreational vehicle, but random variable. Okay? So when x is a discrete random variable, what we have to do is take a look at all the values that x can take on and then weight it by their relative frequency of occurrence. And that weighted sum is what we actually call the expected value of x. Now, what happens if the random variable is continuous? Well, we do a similar kind of thing. Because what we end up doing is we say, okay, we need to take a look at the possible values x that that random variable can take on, and we need to weight it by their relative frequency of occurrence. There's a subtlety in the interpretation. This is the probability density function for a continuous random variable. Okay, so this is the continuous case. And so then what we do, well, when we start talking about things that are continuous or that vary in a differential or incremental way, usually what we end up doing is replacing the summation with an integral sign, and that's exactly what we do. So now what we would do is we would integrate over all the values of x that it can take on. And so that's what we call the expected value of x when x is a continuous random variable. So that's the key. This is what it looks like for continuous random variable. Okay. But the key concept is still this idea of what's the value that occurs and what's its relative frequency or probability of occurrence. That's the key idea. So it's this weighted sum over all different values. Okay. A couple of really important properties of expected values, and the first one is that the expected value operation is a linear operation. Okay. Some of you may have taken the intro control course from me. We talked about Laplace transforms. Laplace transforms are another example of a linear operator. But what this means is that if I want to take the expected value of a sum, that's equal to the expected value of x1 plus the expected value of x2. So the expected value of a sum is the sum of the expected values. And so that's the first property. And the second property for being a linear operator is that if I take the expected value of k times x, where k is some constant, then that's just equal to k times the expected value of x. So in other words, what I can do is I can pull scaling through the expected value operation. Okay, you might say, well, that's nice. Why is that important? Well, where it starts to become really important is later on we're going to talk about, for example, the sample average. And remember, the sample average is equal to 1 over n times the sum of all the samples that we took, like this. And if I want to take the expected value of x bar, then it's the expected value of 1 over n times the sum. I can pull the 1 over n out, and I can then also express that as the sum of individual expected values. And that allows us to make a comment on what we're going to refer to as bias. So that's coming down the road. We'll talk about that in terms of the sample average, and we'll talk about it as well in terms of parameter estimates. But at this point, I just want to emphasize that the really important property of expected value is that it's a linear operation.